Welcome everyone to the third day of EA Global Summit 2021. This is Sujal from the organizing team. It's our privilege to have Knut Jitland in our presence. Knut had a PhD in geomatics and act as a convener of ISO TC 211 Harmonized Model Maintenance Group with responsibility for all UML model and derived resource for implementation. Presenting ISO TC 211 have used UML for development and implementation of standards since 1998. And I also thank everyone for your interest in joining the session. And for your kind information that we will be muting all the participants throughout the session. So please use the chat window to drop your question to the speaker. Your queries will be answered at the end of the session. We request everyone to visit the Alert on Microsoft Teams channel to communicate with Knut and the other EA practitioners after the session. Knut have accepted to stay in the channel to have one-to-one discussion and answer all your queries. The link to the MS Team channel has posted in the chat window for your quick reference. If you have any difficulties in connecting to Teams, please let us know through the chat window or write us at registration@globalsummit.com. Thanks once again for your interest and support to EA Global Summit 2021. Without any further ado, I'll request Knut to start his presentation.
Thank you. So I hope you can hear me all right and see my presentation now.
Yeah, Knut, I can see you and hear you perfectly.
Perfect, thank you. So yes, my name is Knut Jitland, as it was already said here, and I work for the Norwegian Public Roads Administration. But as already announced, in today's session, I will be representing the ISO Technical Committee for Geographic Information, ISO TC211, where I'm privileged to be convening a group called the Harmonized Model Maintenance Group. And in the presentation, I will show how we use UML and Enterprise Architect in our standards for ISO TC211. So ISO TC211 have a long history on the use of modeling technologies for modeling geospatial information. And as already stated, we have used UML as our main modeling language since 1998. And in the presentation, I will give you an introduction to how who ISO TC211 and the HMMG are. Sorry, it's a bit of delay here. There. How ISO TC211 use UML and model-driven architecture, how we store and work with the models, how we work with implementations and documentation. I will give you some example models, and of course, I need to say a few words about the improvements in progress, because I believe that ISO TC211 have quite a structured and well-functioning approach for information modeling with UML and MDA. But of course, there's always room for improvements, and you will probably see that throughout this presentation. So I'll start with a little bit of context. It's a fact that everything happens somewhere. Therefore, the geospatial context of information is essential for a range of domains. For example, building information models, BIM, intelligent transport systems, ITS, GIS, geospatial information systems, of course, life cycle analysis, smart cities, climate, and many other domains. And it's often been claimed that 80% of all information relates to a location. This statement has never been documented, but a German research project from 2013 actually found that 78% of German Wikipedia articles were directly or indirectly related to a location referencing. So you could say that the claim is true, kind of. So ISO TC211 has a scope that is, in short, you could say that it's supposed to establish a structured set of standards for information concerning objects or phenomena that are directly or indirectly associated with a location relative to the Earth. And as we saw from the previous slide, that would concern quite a massive amount of information, as almost everything is in some way located relative to the Earth. So the committee is organized with a range of working groups and advisory groups with conveners and members from all over the globe. And as you can see, it's now been managed by Sweden after many years of Norwegian leadership. And the most essential part of the committee for this presentation is the advisory groups for resources on the right of the organization chart here. And like for everyone else these days, the climate crisis and the work on global sustainable development is important for ISO TC211. And more than 100 standards from ISO TC211 supports a wide range of the UN Sustainable Development Goals. And besides, the committee is deeply involved in the UN Committee of Experts on Global Geospatial Information Management, the UNGGIM. A little bit more of the history. ISO TC211 was established in 1994 with its first plenary in Oslo, Norway that year. And in 1997, it was decided to use OMT object model as a graphical language and Express and Corba IDL as lexical languages. But already in 1998, UML was selected as the conceptual schema language for ISO TC211. And I believe the first version of UML was introduced in 1997, so ISO TC211 was quite early on adopting UML as a conceptual schema language. And in 2002, the Harmonized Model Maintenance Group was established, which I will refer to as HMMG throughout this session. So the Harmonized Model Maintenance Group, which I am privileged to be convening, has a core responsibility to ensure that the UML models and the derived resources for implementation are maintained and made accessible. This means that we shall establish, maintain, and make available a harmonized UML model for the committee. We shall coordinate the use of UML, and we shall coordinate the work on resources for implementation. And this is something we do in close cooperation with the XML maintenance group, XMG, the group of ontology management, GOM, and the terminology maintenance group, the TMG. So this is where we start. There is a real world out there, and our mission is to create a digital representation of that real world. As humans, we see a lot of different features in this picture. We see a road with a pedestrian crossing with zebra stripes. We see a roundabout, a bicycle road, flagpoles, a police station, a football stadium, fences, and some residential house, to name a few. And we want to create a digital representation of these features and present them in a map, something like this, where we represent the different features with different colors and symbology and so on, so we are able to understand what the different features are. And geospatial information is so much more than maps. The information part is essential, as it describes a feature as much more than just the geometry. And as seen in these pictures, we want to create a full representation of the real world, which we can present in 3D as well as in 2D. And where the individual features has information that can be used for construction of a new reality from a design model. So we need to classify and represent features from the real world as classes with properties. For example, the railing is represented as a complex volume geometry. That geometry has a position in the real world, and the railing is of some type from some producer, which is information that the contractor can use for building the new road. So the process of information modeling is not unique for ISO TC211. This figure from ISO 19101, the fundamental standard for TC211, it illustrates a well-known process for information modeling in general. We start with a fuzzy cloud that we refer to as the real world. From this fuzzy cloud, we select a universe of discourse that we want to create a conceptual model from. In order to do so, we need some kind of conceptual formalism that we use to provide concepts for describing this conceptual model. And this conceptual formalism is a basis for one or more conceptual schema languages, which we then can use for representing the conceptual model in a formal way in a conceptual schema. And ISO 19103, the conceptual schema language, states that UML is the chosen language for ISO TC211 standards. And it also provides a UML profile for use in models of geospatial information. And furthermore, model-driven architecture, MDA, as described by the object modeling group, management group, is an important fundament for ISO TC211 standards, where we have defined levels of abstraction according to the levels in model-driven architecture. We have two levels of platform-independent models, where we have at the top, we have the abstract conceptual models, where we describe abstract concepts for networks, for time, for geometry, for location referencing, and so on. And then below these abstract models, we have domain models, for instance, for transport network, for buildings, for real estate or whatever. And these domain models, they use these abstract concepts. And as you can see, several domain models use the same concepts. And from these platform-independent models, we can derive platform-specific models prepared for implementation in more specific technologies, such as GML, which is an XML dialect specifically for geospatial information, or in SQL scripts, or in JSON, or whatever. And then again, from these platform-specific models, we can, of course, derive the implementation schemas. Implementation schemas for GML, which is XSD, XML schemas, SQL scripts, and so on. And more specifically, ISO TC211 defines 4 levels of abstraction in ISO 19103. At the top level, we have the meta models. With the UML meta model, we have something called the general feature model. We have our UML profile from 19103. And then at the next level, we have the abstract conceptual schemas that I referred to, like the 19107, the spatial schema that defines different types of geometry, how they are described. The ISO 19108, the temporal schema, which describes the temporal part of geospatial information, and ISO 19111, which is the standard for how to define a coordinate or a reference system for example, coordinate referencing related to the Earth, which some may know as the basis for the EPSG registry. And furthermore, below this, we have the application schemas, which are, for example, in the Inspired, OGC, CityGML, and other more specific models that reuse the abstract concepts from the level above. And then again, like I said in the previous slide, we are able to derive the implementation schemas for GML, for OWL, and so on from these application schemas. So at the 3 upper levels here, we use UML. And at the implementation schemas, our main implementation schema in ISO TC211 is the GML format. But we have also started to work with OWL. We're using GeoPackage from OGC and several other formats. And the point is that from these conceptual models, you can basically derive any kind of schema as long as you are modeling according to the rules. And ISO TC211 has a main scope at the upper 2 levels, while other organizations create the domain-specific application schemas. And we will come back to them later. So the complete framework for the use of UML and MDA for geospatial information consists not only of the distinct levels of abstraction and the meta models, but also of modeling rules and how they are used. For the models being developed at the abstract level and at the application schema level, they need to be modeled according to UML modeling rules. And then if they are modeled according to UML modeling rules, we are able to convert them to implementation schemas by applying conversion rules that are defined in other standards. So these UML modeling rules and the conversion rules are an important part of the MDA framework for ISO TC211. So, like I said, ISO 19103 defines the formal UML profile for geospatial information with focus on meta classes for class and package diagrams. We are actually using a quite small part of the UML specification, mainly class diagrams and package diagrams. And the main concepts to be used in information models for geospatial information are, like you can see here, the interface, the package, data types, enumerations. And besides, we have defined two specific concepts for use in geospatial information. This is the union metaclass and the code list metaclass. And like I said, ISO 19103 also define rules for the use of UML. You can see that the UML profile shows up at the upper level in the figure from the previous slide. But then again, there's also the modeling rules that are described in the standard, such as every element shall have a definition. Class names shall be valid SE names and in upper camel case style, and property names shall be in lower camel case, and so on. And every navigable association shall have a role name. And besides 19103, we also have 19109 that defines more specific rules for the modeling of the third level of abstraction, the application schema level. The title of 19109 is Rules for Application Schemas. And one of the important parts in 19109 is the general feature model, the GFM. The GFM defines how real-world phenomena shall be classified in feature types with properties and associations and represented as features. In the ISO TC211 terminology, a feature is defined as an abstraction of a real-world phenomenon, while a feature type is defined as a class of features with common characteristics. So, for example, the railing we saw in a previous slide will be represented as a feature of feature type railing. And likewise, the pedestrian crossing will be in another image would be represented as a feature of feature type pedestrian crossing or something like that, and with some properties. So the general feature model is described as a meta model, and it is implemented in the MDA framework as a UML profile that extends the 19103 profile. And like 19103, 19109 also define rules for the use of UML, but then more specifically for the application schema level. 19103 defines more general rules for how to use UML, while 19109 is more specific on the rules for the application level. As UML is quite important for us, we have also created a best practices wiki in order to achieve UML models that are fit for use and understanding by humans as well as by machines. And in this wiki, we have described some best practices for UML modeling, diagram design, and documentation. It includes an introduction to UML, best practices for modeling, best practices for designing class diagrams, tools for model documentation, and references to some scripts. And this wiki is open and accessible for anyone who wants to look into it. And we have also organized a repository of scripts for working with UML models based on ISO TC211 standards. This includes different kinds of scripts that committee members have developed for use in their work, either for work in the committee or in the national models. The scripts are used for changing, documenting, or validating models, and could be, for example, for checking conformance with modeling rules. For example, checking if every element has a definition. So as you can understand, UML models are quite important for ISO TC211 standards. I would go so far as to say that the UML models are, in fact, the standards. The standard documents are the formal standards, and they are the formal representation of the models as text and figures. And they, of course, they add normative statements, conformance clauses, and conformance tests that you need to be able to claim conformance with the standard. So you do need the standard documents, but the UML models are the originals. As you can see for this example from the metadata standard ISO 19115, a simple UML class diagram showing how to describe an extent of a data set. And we will come back to this figure later in relation to implementations as well. So I already showed you this figure, but I will come back to it once again, because a fundamental part of the MDA framework is the ability to derive implementation schemas directly from the models. And we have 3 ISO TC211 standards that define rules for conversion from UML to implementation schemas. These are ISO 19136, the Geography markup language, which we know as GML. This is a very important standard for ISO TC211 as it describes the XML used for geospatial information. ISO 19136 also contains rules for UML modeling in order to be able to generate GML schemas. So then we're talking more about platform-specific models. And besides, it also, of course, has the rules for conversion from UML to GML. Besides, we have ISO 19139. This is more general rules for conversions from UML to XML, because not everything shall be implemented as GML. Some standards may be implemented as more generic XML. And finally, we have ISO 19150 Part 2 ontologies that describes the rules for conversion from UML to OWL. So we are able to derive OWL ontologies from these standards. Of course, for people working with ontologies originally, it will not be the same structure. It will be a UML-ish flavor of it, but it's possible to use them further in the semantic web world. And of course, the conversion rules or the success of these conversions rely on models that are modeled according to the modeling rules. And through this MDA framework and the modeling rules and the conversion rules, we are able to derive standardized implementation schemas for the ISO TC211 standards from the Harmonized UML model. We derive XML schemas, which we store at or maintain at the schemas.isotc211.org. This is the responsibility of the XML maintenance group, the XMG. And we derive ontologies, which we store at def.isotc211.org. This is the responsibility of the group of ontology management, the GOM. And both schemas are stored in a standardized structure with standard number, part number, year, version, and namespace, and then stored at the main schema site isotc211.org, or the resource site. So the schemas are the standardized resources for implementation. As I said, the standard document represents the model as text and figures, and it adds normative statements, conformance classes, and conformance tests that you need for implementation of a standard and to claim conformance. And as I said, the UML models are the originals, but the schemas are the resources that people need to be able to implement these standards. So we need these standardized schemas in order to make sure that implementers use these standards in a harmonized way. So for those who remember the simple UML diagram I showed some slides ago, we have the same model here described as an XML schema here, the extent with the geographic element, the temporal element, and the vertical element. And above, we have the ontology representation shown in Protege. With the extent, the geographic extent, temporal extent, and the vertical extent. And as stated earlier, the main scope of ISO TC211 is at the abstract levels, the meta models and the abstract conceptual schemas. The domain-specific application schemas and their implementation schemas for various technologies are developed by other organizations, but their work is based on the MDA framework from ISO TC211 standards. These application schemas reuse elements from core abstract ISO TC211 models for, like I said, spatial referencing, the geometry from spatial schema, temporal schema, and so on. And that way, we make sure that models of geospatial information from various organizations and applications domain from all over the globe are based on the same basic concepts and are prepared for integration. So you can use the information independent of application, software application, and independent of administrative borders. So just to show you some examples at the global, at the regional, and at national level. I already mentioned the OGC, the Open Geospatial Consortium, which is a huge organization for standardization in the geospatial community, and we have a close cooperation with OGC. They develop specifications like CityGML, Land Infra, IndoGML, and so on. And from the names, it's obvious that these are GML specifications. I also mentioned the UNGGIM, and we have the International Hydrographic Organization, the AHO, which is a huge user of ISO TC211 standards for their hydrographic standards. At the regional level, we have, for example, Inspire in Europe, which have described an infrastructure for spatial information in Europe with a range of data product specifications for geospatial information that the member nations in the European Union are required to provide information according to. For example, for transport networks, for buildings, for utilities, and much more. And then finally, at the national level, we have the national mapping authorities, such as Geonovum in the Netherlands and Kartverket in Norway. So all of these specifications, they use the MDA framework and they use the ISO TC211 abstract concepts in order to create their application schemas and derive their implementation schemas. in order to achieve a harmonized maintenance and access of our UML models, we have collected all UML models in a harmonized UML repository, the Harmonized UML Model. This work started already from the early days of our use of UML and led to the decision of establishing the HMMG in 2002. So in the Harmonized UML Model, we store all editions of all ISO TC211 standards or the UML models from those. Of course, there are some standards that don't have UML. And for example, if we look at ISO 19109 that I have already referred to, we can see that it has two editions in the Harmonized Model repository. So we store all of these editions and keep creating new versions here. And the Harmonized UML Model is important because it makes us enable us to reuse elements from the abstract schemas into other abstract schemas and into other application domain schemas. So we reuse a lot of these elements internally in ISO TC211 standards, and not least they are used externally in OGC specifications, in Inspire, in other domain models, and in national models, for example. So just to show you an example of internal dependencies, we can look at ISO 19116, which is a standard for positioning services. As we see from this package diagram, this standard depends on several other ISO TC211 standards. It depends on ISO 19103, ISO 19111, ISO 19115, and ISO 19157. So without the harmonized model, it would be difficult to enable this kind of dependencies, and you would have a big risk of different standards creating the same concepts over and over again. So we have several ways of accessing and working with the harmonized model. We are using the Sparx Cloud repository. So we have the harmonized model stored in a cloud repository where we have the latest versions of all approved changes for all models. As a part of this, we are also the models available on the ProCloud Web at the iso.sparxcloud.com address. And we are publishing parts of the standards or parts of the models through reusable asset services, so other users can import these packages into their EA project. But besides, we have also established a framework with GitHub resources, where we have a standalone EA project that is periodically synchronized with the ProCloud. And we have a standalone, more editorial project where we have the more work in progress standards included. But the ProCloud and the RAS are the primary repositories, or the ProCloud is the primary repository. And the EA projects on GitHub, they are provided for convenience for users. So the ProCloud web version can look something like this, for instance. This is from the ISO 19156 edition 2 standard, which is under development now. And as you can see here as well, that this standard depends on several other standards from ISO TC211. As I said, we are also using GitHub a bit. So we have 2 EA projects that we update on, or that we share on GitHub. And besides the EA projects, we have XML files that we export from the harmonized model and upload to GitHub. And we also have a wiki at the HMG GitHub that describes how to work with a harmonized model, how to use the concepts there, what kind of prefixes are used. We have some prefixes for some classes and so on. And this is also a completely open repository, so anyone can basically download the EA projects. I'd like to share some experiences from our work. We see that we have project team members from all over the globe, from various kinds of states, so to speak, and from many different organizations. So some of them have some technical restrictions that they are not allowed to work or not able to work with cloud repositories, for instance. This could be restrictions set by governments, but it can also be restrictions set by employers. So we need to enable that the project teams can work with the harmonized model in different ways. So we have the cloud repository, which is the kind of the preferred way of working, because there they have the direct update with the latest version. The downside of the cloud repository is that we don't have a version control implemented in it. And we also experience some challenges with response time, which is actually varying from different geographic locations. We have seen people working in the US, in North America, that it works quite well for. While here in Europe, it works, it's too slow. Simply, we cannot work with it. It's I don't have the patience to work with it, at least. And I also tried working with it from a meeting in Japan and had the same problem there. So we have some challenges with the response time there. So therefore, due to these challenges and due to the restrictions that some organizations have, we upload or people work in the local projects. And that also gives us the ability to use XMI file version control on GitHub. So we have a manual XMI import, export by the project teams or by the HMG. The changes aren't that frequent, so we can live with the manual export and import of the XMI files. And besides, of course, we need the manual XMI import into the cloud repository and into the official online offline projects and to the RAS. We need to publish new RASs as well. So this is something that the HMG does. And even though we consider the UML models and the implementation schemas as the most important part, the main official outcome of a standardization process is the standards document. And earlier on, these documents were written manually and in parallel with the modeling work. This was a time-demanding and, of course, also an error-prone approach. And we are now cooperating with a company called Ribose for an automation on the documentation, where we have updated documentation according to the ISO template, which is being derived from the UML model. And by using scripting and Metanorma and ASCII-Doc, they are able to update documents instead of producing a complete new report each time a minor change is done in a model. So, for example, the newly published standard ISO 19170 Part 1 was almost fully generated from the EA model. As it says, it was 90% generated. You still need to do a bit of manual work. We are also using it now for several standards in development, and it's a very promising way of working with the standards document. And I know Ribose are involved in several other ISO committees as well, and also with the OGC. So I will now show you some examples on domain models that have been developed on the fundament of ISO TC211 models from the harmonized model. The models are from the 3 application domains, so GIS, Geographic Information Systems, BIM, Building Information Models, and ITS, Intelligent Transport Systems. These 3 application domains, they all operate on the built and natural environment in a geospatial context. For example, a road infrastructure like we see in this picture. GIS applications are used for analyzing and presenting the existing natural and built environment, while BIM applications are used for planning and developing and constructing a new built environment, which will change the existing natural environment as well. And then afterwards, in maintenance of the built environment. And then we have ITS systems that are used for planning and controlling transportation and need the same information about the infrastructure. So once again, if we look at the railing, the railing will be first created in a digital version in a BIM model when the new road is planned. Then the road is constructed, hopefully, with the use of BIM processes. And for this, they need the type of railing, they need some kind of number of nuts and bolts and so on. But after this road has been built, we need to update the GIS with the new natural and built environment. And in the GIS, we may want to, for example, analyze noise pollution. And for that concern, the railing is an important feature that can either reflect or absorb noise. And finally, in the ITS domain, we also need this railing, which an automated car will experience as an obstacle that they cannot cross. So for the sake of interoperability between these different uses of geospatial information for a built and natural environment, we need to have one approach for modeling geospatial information. And as you will see now, the approach from ISO TC211 have been used for domain models in all 3 domains. I will start with the ITS domain, the Intelligent Transport Systems. In this domain, there is a need for providing authoritative information from road authorities to map providers such as TomTom and HERE. This could be speed limit, turning restrictions, weight restrictions, and so on. And the European TN ITS specification is developed for this purpose. The specification is developed as an ISO TC211 conformant application schema with implementation schemas for GML and OWL RDF. And this model is now being used by a range of European nations for providing authoritative information to the map providers in order to make sure that the automated vehicles know how to drive legally and safe. And on the other side, we have the more construction part of a road. And the Open Geospatial Consortium, OGC, have developed, like I said, a range of specifications. And among these are the OGC LAN Infra GML specification, which reaches out towards the BIM domain by defining models for infrastructure projects. This particular model that we see here is for the construction of road infrastructures with the different surfaces and elements that together form the shape of or that together shape the body of a road. And in the BIM domain, we have the Industry Foundation Classes, IFC, which is the most prominent information model in the application domain of building information modeling. IFC is, as some may know, modeled in the Express modeling language, but there is work in progress for switching to UML. The figure in this slide is an example of how the Express model can be converted into ISO TC211 compliant UML, and through this implemented in, for example, the Geospatial XML format GML. And I have to say that this example is from a research project. This is not an official IFC model. It's an example of how the IFC model can be represented in an ISO TC211 environment. As stated in the beginning of the presentation, I believe that ISO TC211 have quite a structured and well-functioning approach for information modeling with UML and MDA. But of course, there's always room for improvements. And one example that we have now is the revision of the fundamental standard ISO 19103, the conceptual schema language. Among the issues, or among other issues, this revision will focus on a better conformance to the UML specification, because we have seen that the existing UML profile has some problems with the UML specification. It's not according to the UML specification. We are trying to create a better structure of UML profiles with a general feature model, for instance, that is now in another standard. We are trying to implement semantics for improved implementation in OWL. And we are also reaching out towards the more semantic world with top-level ontologies according to ISO, the newly published ISO 21831 Part 1. And as we saw in an earlier presentation today, MDG technologies is of course also important for simplify the use of our profiles. So we will probably also create MDG technologies based on our profiles. That will be a resource for implementation, just like the implementation schemas. Another improvement that we are working on is a conceptual model for modular specifications. We have tested this model for implementation as a UML profile. And the idea here is to maintain all requirements and conformance classes that are normally written in the standard document. We want to maintain them in the UML model together with the conceptual model for the standard. And this is then, of course, a part of the improved automated documentation process. So to start summarizing, I have showed you now how ISO TC211 use a generic way of defining information models based on a real world and universal discourse in order to create a conceptual model formally represented in a conceptual schema based on UML. And furthermore, model-driven architecture is extremely important for the ISO TC211 approach, with the different levels of abstraction, with the meta models, the abstract conceptual schemas, the conceptual application schemas, and the implementation schemas. And we have the derived resources for implementation that we maintain on isotc211.org, the XML schemas and the OWL ontologies. And finally, as I already said, the UML models are in fact the standards, and the implementation schemas are needed for implementation of the standards. And of course, the standards documents are needed for the normative statements, the conformance classes and conformance tests, and so on. So you still need to buy the standard, but the UML model is the original, and the implementation schemas are what you need in order to implement it. So I believe that was my last slide. No, yes. So thank you for listening. I suppose we may have some questions, comments, or concerns in the chat here.
Thanks, Knut. I thank Knut on behalf of everyone for making this session a wonderful one. And we can see there are no questions asked yet. So we'll wait a couple of minutes for the audience to put their questions in the chat. Knut, Mario is asked a question. Do you think that sysml can be used for your purpose?
Maybe yes, depending on the kind of standard, because we have some standards focusing on the information models and some focusing more on the systems, on the processes, on the services, and so on. So definitely other parts of UML and UML related tools or languages may possibly be useful for our work, yes.
Thanks, Mario. Thanks, Knut. So we request everyone to post their questions in the MS Team channel. And thanks, Knut, and thanks to everyone for your time and support throughout the session. Hope it's very informative and gives a deeper insight into the topic. Now, Knut will be available in MS Teams to have a detailed discussion and answer more questions. The link to the MS Teams channel is posted in the chat window for your quick reference. If you have any difficulties in connecting to Teams, please let us know through the chat window or write us at registrations@eaglobalsummit.com. Thanks once again, everyone, and looking forward to host you all in another wonderful session. Thanks, Knut. Thanks all.
Thank you, everyone. Thank you.